The tech industry has been lying to you for 20 years about moving fast and breaking things. Speed and durability are not opposites. They are just calibration decisions that most engineering teams are getting completely wrong. Every time a software project fails, it is usually because some loud voice in the room forced a blanket ideology on the entire team. You either get the reckless speed guys who ship garbage without ever checking if it actually solved the customer's problem, or you get the enterprise architecture guys who spend 6 months diagramming a prototype while a competitor steals the market. Both of these approaches burn budget and produce massive waste. The real question is never whether you should go fast or build it right. The only thing that matters is what a specific component requires at a specific stage of its life cycle. If you want to stop burning money on failed software delivery, you have to look at every single thing you build through 2 lenses. First is the blast radius. If this thing breaks, who goes down with it? Are we talking about 3 people using an internal admin dashboard? Or are we talking about every single customer transaction failing at checkout? Second is the reversal cost. If we deploy this and it is completely broken, how hard is it to undo? Changing a button color takes 2 minutes to roll back. Migrating a database with 10 million rows on a live production system is a nightmare to reverse. When you map blast radius against reversal cost, you get the only 4 ways you should ever be building software. If the blast radius is low and the reversal cost is low, you are in prototype territory. This is where you ship fast and learn fast. If it works for the immediate use case, push it live. Spending weeks writing automated tests and architectural documentation for a feature experiment that might get deleted next month is just durability theater. It is a complete waste of time. Now, if the blast radius is low, but the reversal cost is high, like a back-end data migration, you need to ship carefully. It might only affect a few internal users, but if it breaks, you are stuck with corrupted data that is incredibly expensive to fix. Speed does not matter here. What matters is scoping the change tightly and having a rock-solid rollback plan. If the blast radius is high, but the reversal cost is low, like a massive UI update, you ship fast but with heavy guardrails. You push it out behind feature flags. You monitor it aggressively. If it breaks, millions of people might see it, but you can toggle it off in 3 seconds. Then you have the high blast radius, high reversal cost quadrant. This is the core payment engine. This is healthcare patient data. This is compliance infrastructure. There are no shortcuts here. If a failure harms a person, destroys irreplaceable data, or triggers a regulatory audit, you slow down. You do the extensive testing, the formal code reviews, the staged rollouts. Anyone trying to sprint through this quadrant is just building a bomb. This framework is especially critical right now because AI code generation is making the reckless speed problem so much worse. People are vibe coding entire code bases with AI and pushing them to production without review. AI is great for accelerating the actual typing of code, but it does not replace the judgment layer. You can use AI to write a draft fast, but if that code lives in a high-risk quadrant, it still needs to go through the exact same rigorous testing gates as human-written code. Speed improvements that just generate more code without validating it do not give you faster delivery. They just give you a massive inventory of technical debt. Stop letting your teams apply a single definition of done to every piece of code they write. A single product can have a payment gateway that requires military-grade rigor and a marketing page that can be updated 3 times a day. If you treat them both the same, you are either over-engineering the trivial stuff or under-engineering the critical stuff. Figure out what quadrant your work lives in. Adjust your standards to match the actual risk. And stop treating software delivery like a religion.